Okay, so the next out is two glass bulbs of equal, equal volumes are connected by a narrow tube and filled with a gas at temperature 27. So let's say this is the glass tube. So this is one, and it's joined with a narrow tube to another one. Maybe not be that big. Okay, so we can have a narrow tube to another, like a small dumbbell. They are having same volume, gas at temperature 27. So let's say this is the initial temperature. Okay, pressure. Okay, initial pressure. One of the bulb is now kept at 127 degrees Celsius. Anyone, let's say this is 127. Okay, so this is the new temperature, T2. Okay, and this will still remain 27 degrees Celsius. One of the bulb is kept at 127. Then the new pressure inside the bulb. Now, what you understand is, as I heat one bulb, temperature increases, so pressure will also increase because volume is constant. So what will happen? The pressure inside increases. Here pressure is not changing, so more gas from here will start flowing here, and eventually the pressure will become equal both sides, because if the pressure is not equal, the gas will continue to flow from one side to other side. Eventually this will become vacuum. That's not possible. You can't just heat it to 127 and get a vacuum here. So yes, the gas will initially flow, but since the temperatures are remain constant, volume is constant, eventually the pressure will become equal on both sides. Okay, so number of moles will be less here because gas is flowing here. Here the moles will increase, it will compensate. So you need to understand finally the pressure on both the sides. Let's say this is one P1. So here I'll say it is T2 and P2. Okay, they'll remain the same. And we know pressure is from the ideal gas equation. PV is nRT. So it's N1 RT1 by V1 is equal to N2 RT2 by V2. It's just ideal gas. V's cancel, volume are equal. R cancel, so N1 T1 for me, T1 is 127 Celsius plus 273 will give me 400. N2 I don't know, T2 is 27, which is 300 kelvins. So 4N1 is equal to 3N2. This is the relationship between the number of moles. Number of moles will be different, obviously. Okay, right. Now what did they ask me to find? The new pressure, which means P1 or P2, either way it's the same. Let's say I want to find P1. So I have to see something is equal. Now what you can say is, whenever you have an ideal gas, try to see something that remains constant in both initial and final. Look at this. So PV is equal to nRT. I can see that N will always remain constant, whether you heat it or change it, whatever you do. This R will not change. Okay, R will always remain constant. So what is R? PV by NT is equal to R, both initially and finally. Okay, so initially, let's look at this bulb. Okay, initially in this bulb, what was the pressure? Initially this was the pressure. Let's say I call it as P. This was the pressure. So P initial, volume was V by N is remember, now if the number of moles here is N1 and N2, initially the number of moles will be equally distributed between both of them. I hope that's clear. Okay, so what would have happened is the number of moles is N1 plus N2 by 2, because initially both of them were the same temperature, so they will have the equal pressure and equal number of moles. And T is T initial. Now this should also be equal to the final, this term, because R is remaining constant. Finally, now what do you have? P1, V is same, N is N1 and T1. V cancels off. I want to find P1, so I can cross multiply, but I think I can substitute for N2 here because I have N1 here. I'll try to cancel. So what is N2 from here? Let's take 2 Pi by Ti. N1, let it be like that. N2 is 4 by 3 N1. 4 by 3 N1. This is equal to P1 by N1 T1. Okay, so N1 I can cancel off. So I'll be getting 7 by 3. So it goes to the top. So this is 6P initial by I think so N1 cancels. So maybe I'll write 7 N1 T initial. It is Pi by N1 T1. N1 cancels finally. Okay. So now what do we have? Just have to substitute. Will I have space? Yes, I think I'll do it here. So 6 into Pi. This is P1. Sorry. Pi initial is 77. It will be like that. 77. Yeah, it's good number. T initial is 27, which is 300. T1 is 400. Okay, let's substitute. So 6 into 77 cm of Hg. I'm not writing that by 7. T initial is 300 is equal to P1 by T1. What is T1? T1 is 400. So this cancels off. This is 11. And you see, even this I can cancel. See, this is 3 times, this is 2 times. So what I have is 22 into 4, which is 88. So P1 is 88 centimeter of edging, this part. So 88 centimeter of edging. I hope this is clear. If you have any doubts, inform me in the Telegram channel. So if you like the video, hit the like button. So keep practicing. All the best.